Hello and welcome back to the CCTV IP Academy. In this episode, I will try and summarize the differences between image compression and video compression, and also explain where would you use one and where would you use the other. First, the image compression. As we said earlier, that is a compression in two dimensions. Each image that is compressed is independent of what comes before or after that compression. The results are compressed images that we usually refer to and measure in kilobytes or megabytes per image. The actual events that are being taken with such compression may be quite few seconds or part of a second apart. That needs to be very clear before putting a system together with image compression, because every image may be completely independent and separate from the previous, but there also might be a big gap between subsequent shots of a particular camera of a particular compression. So typically image compression we would use in events which are happening only once and we know when they happen. Like, for example, we want to capture a number plate of a car passing by a particular area. Like when we have perhaps a hold up in a bank where a duress button can be pressed at one time and maybe a high quality megapixel camera takes a shot. But it's important to understand that image compression does not follow number of images a second as easily as the video compressions, as we said earlier. It is also important that because of the independency of image compression between images in the image compression can be multiplexed. So in other words, in the past and even still today, we have digital video recorders that can mix multiple different cameras because each image of each camera is independent of each other, but we can still put them in one location, on one partition of a hard disk, and later on with a playing back, we can decode every one separately. Video compression, as we said earlier, is a three-dimensional compression, where the two dimensions is the horizontal and the vertical of an image, of a pixels product, and the third dimension is the time. Because of that, video compression is more efficient than image compression when you consider the number of images produced. And typically for PAL, we want 25 images a second to call it live. For NTSC 30, that's what basically is achieved most efficiently with video compression. Another important thing with the video compression is that we can also record audio, because most of the video compression standards, such as MPEG-1, MPEG-2, MPEG-4, H.264, they all have ability to add the audio to the video compression. So clearly, the most common application for video compression would be in places where CCTV monitors and covers and protects areas such as banks, where there are a lot of people, in shopping centers, especially important for casinos, where every single movement of hands and cards and dealings has to be monitored closely. And as such, video compression is irreplaceable. Another very important reason for using video compressions in many systems, CCTV systems, is the large requirement for large storage. Because of the efficiency of the compression, where the time is used as a third component, the actual storage capacity can easily be achieved 7 days, 14 days, or even maybe more by appropriate choice of the compression rate without losing the quality, of course. And finally, the so-called IP cameras, such as this one that doesn't have the actual BNC output, would usually produce a video in IP format with IP streaming when using video compression. And let's now try and explain the little bit of a difference between image compression and the video compression. So, if this is a normal camera, the first thing that the camera signal is being done onto is converted to digital. Then we go into the compression, which is in this case 2D compression, image compression. So horizontal and vertical pixels are being divided on blocks of 8 by 8 and so-called DCT applied to it. This is how JPEG compression is achieved. We should also mention here perhaps that this doesn't necessarily apply just for standard definition analog camera. JPEG compression is applied even on megapixel cameras. Same concept of dividing blocks in 8 by 8, which is actually also the reason why sometimes if we go too far with the compression, so-called blocky artifacts appear. These are the blocks of 8 by 8 that will become different to the neighborhood 8 by 8 blocks, and this is the JPEG artifacts. With the video compression, same signal again is being converted to digital and then undergoes so-called three-dimensional, which is in this case the video compression. The importance here is that the time is the factor that is taken into account for producing a so-called group of pictures. That is basically a sequence of images that simulate or represent a live streaming, 25 images a second. Because of time being into consideration in this compression, the compression is becoming more efficient. Even though every one reference image in such a GOP, group of pictures, is compressed using the same compression as with the image compression, that is in this case the DCT, but further images are actually calculated from the previous and the following reference images and predicted images. So the efficiency in that case using video compression is much higher. This is the reason why if we have 166 megabits per second live streaming of a digitized signal, that without compression will become 166 megabits per second that we said earlier. Once it's compressed, for example, with MPEG-2, with the same compression that is used on your DVD player, that compression actually squeezes the 166 megabits per second down to about 4 megabits per second only. And as you would know from your experience, the quality of that is almost as good as the live camera with insignificant losses for human eye.